In this video, we are going to wrap up the part about components of time series, and we are going to see how we can examine the residual plots and see if we forgot something. So when you look at the residual plot, normally everything should be centered around 0 everywhere, but you might have a trend like this one where you have a consistent increase or decrease with time. It doesn't need to be a line, it could be a curve, but as soon as it consistently increase or decrease, you have a trend that you need to account for. Now, if instead you see regular peaks and valleys and they have to be regular, so at the same kind of intervals, then you have a seasonality problem and you need to create indicator variables to account for that. Finally, if you have positive and negative errors that tend to be followed by the same kind of positive or negative error, then you have an autocorrelation problem. But if you cannot predict it because it's not regular, then you have a cycle. And in that case, you would include either a leading indicator, so a variable that you know could predict a change in the cycle, or you could put a lagged variable, so the dependent variable, but maybe 2, 3, 4 periods behind. So what about the noise, the last component? Well, that's the part you cannot explain by using a trend or a seasonality or cycle terms in your regression. It's similar to the regression residual. Ideally, you want it to be unpredictable, so always around 0. Noise will likely be the main issue that prevents you from identifying trends, seasonality, and cycles, because when the noise is larger, it's difficult to discern these other components. So here is an illustration of this. We can have a time series where first we have a trend, and then we can have seasonality, and then maybe we have some cycle. If I add these 3 components together, I get something like that. So that's the clean data. Now, if I add a bit of noise, you can see we have small deviations from the clean time series. I still have a pattern where I can see roughly the trend, the seasonality, and the cycle. However, if I add a lot of noise, I might get something like that, and now it's not clear at all that I have a trend or that I have seasonality or even a cycle. It might look just like the noise. So be careful when you look at time series. Sometimes it's very clear and you can identify trend, seasonality, and cycle. Sometimes it's more difficult like that and you have to go step by step. First, run a regression and identify the trend, and then look at the residuals and see if you find seasonality or a cycle, and then correct for that. And then you put the next component one by one until you have something that's mostly explained, or as much as you can at least. So now when you work with time series or when you report time series, it might be useful to show all the different components you've identified. So sometimes you'll see graphs like these, where you have at the top the observed values, so the raw data. Then here we have the trend, and instead of using a linear trend or a curvilinear trend that's very strict, they use the flexible trend. And so this trend also includes a cycle in it. You can see small deviations that are unpredictable, so small peaks and valleys. Then you have the seasonality, and here it's useful to report it separately because we can identify the frequency of the various seasons, the frequency of the repetition. And finally, we can see the random noise, and we can see that here it's mostly around 0 and moving unpredictably above or below with very few autocorrelation. So this is a typical way to report time series. You should get familiar with it, and you'll see that most packages or most software will generate this automatically if you ask it.